So it's finally time to introduce the Caesar cipher. It's a relatively simple way of encoding secret messages. In fact, for much of the 20th century, a popular toy was a secret decoder ring which children used to encode secret messages to each other. That was an analog version of the Caesar cipher. If it's so simple, you might ask, well, why did Caesar use it to encode secret messages for some of his most precious information? But of course, back 2 millennia ago, very few people could read or write, so they would have just seen something and interpreted it as meaningless anyway. Here's how the Caesar cipher works. You simply take each letter of the alphabet and shift it to a fixed location in the alphabet. In this example, which is the example that Caesar himself was purported to have used, I've shifted everything by 3 letters. So A becomes D, B becomes E, C becomes F. In cryptography, you can think of this shift as something that's called a key. And so here really for the Caesar cipher, I'm demonstrating the cipher with a key of +3, meaning shift everything 3 to the right. 3 is not a special number other than that it was the number that Caesar repeatedly used. You could use 7 and A would become 1, 2, 3, 4, 5, 6, 7, H, and B would become I, and so on. As an example of writing a message in secret code using the Caesar cipher, consider the word Caesar. Let's shift C 3 places to the right to make F, A 3 places to make D, E 3 places to make H, and if you did this for the entire word, you'd end up with FDHVDU. So if you know that the key is 3, it's very easy to also decode messages. Here's an example of taking the message we created, FDHVDU, and decoding it using the Caesar cipher. As you might expect, D becomes A, and E becomes B, and F becomes C. This corresponds to a shift to the left of 3, or because I called the shift to the right +3, this is a shift of -3. You can see why this is a popular cipher to introduce cryptography to younger students, because it's very easy to write it down and understand the concept of just shifting through the alphabet by a set number of letters. And for simple messages like Caesar becoming FDHVDU and back again, you could probably just crack this yourself, particularly if I told you the key was 3. But if you didn't know the key, if the key could be any number between any possible shift in the alphabet, so any number between 1 and 26, 26 would return the message to its original state, it might be a little harder to crack. You've also got to throw in that it's easy enough to write short messages, but it could take you hours and hours and hours to, say, translate a large book, like a book of the Bible or some Shakespeare perhaps, whereas a computer could do that extremely quickly. And of course, the ciphers used in cryptography today are far more complicated than a simple Caesar cipher, but the concept of a key still remains.